Hey, it's Jag, and we're back on track.
Yeah.
Well, after a little bit of excitement and some minor smoke, we're back on track. As you saw in the last video, I did make a mistake in wiring the transformer and ended up replacing that with a new unit. Today I'm populating the turret board and installing it to the chassis. So the first thing to do when you're doing any work like this is make sure you get your workflow set up so things can go really smoothly, quickly, and easily. Everything you need is right in front of you. Like I did in the Triwatt build and also in the mystery double pedal build, I have taken all of the components I'm going to need and I have put them in this foam. And I have labeled next to them what their value is. So when I'm working on this, I can just grab the part that I need right away. I don't have to search around, dig for it in the parts. The other thing that I did, and you should do, is take your multimeter and measure them. Verify that they're within spec. You can do that for your resistors. You can do it for your capacitors. You can do it for diodes if you have a diode test on your meter. I even test the switches to make sure that they are working. The pots, you check the pots across all three tabs. Make sure that you have full resistance between tab 1 and tab 3, and then put your clip on the middle tab and check that when you vary the pot, the resistance changes. When I say within spec, the components have a tolerance rating anywhere from 1 or 2% up to 10 or 20%. So that means whatever value that component is, it may be low or high by that percentage. 20% would be pretty extreme. What I do when I'm measuring my components, as long as they're within 10% of the rated value, whether that's 10% high or 10% low, I consider that good. As I've said before, I think that's where the character comes from in amps. No two amps will be exactly the same that way. Some people are really picky. They measure, they buy their components in bulk, they measure them, and they take all of their components within a certain specified range, maybe 2%. And as long as those components fall within that tighter range, they will put it in their good bin. But as I say, that's where amps get their character from. So as long as it's within 10% of the rated value, I'm good with that. The other thing that you can do, and I showed this in a longer video about a year ago, you can look that up, but your foil capacitors, orange drops, Mollerups, any foil cap, you want to check where the outer foil is. These capacitors are not polarized in the sense that they have to go in one way or the other or they won't work. But if you identify which lead is connected to the outer foil and you connect that to the most grounded side of the circuit, it will help shield from some noise. So what do I mean by the most grounded side of the circuit? Obviously, if this capacitor was going in and one side was definitely connecting directly to ground, you would connect that outer foil to that side, and then the other lead would go on to the circuit. If you're using this in between stages, let's say as a coupling capacitor between one tube output to another tube input, so from the plate, which is the output of the tube, to the grid, which is the input of the next tube, typically the output is a lower impedance and the input is a higher impedance. So you would orient that outer foil so that it was toward the low impedance side, which is the most grounded side. So low impedance, closer to ground. High impedance, farther from ground. I showed two ways to identify the outer foil on a cap. Sometimes the caps actually have a band marking the outer foil, or it's supposed to mark the outer foil. That's not always the case. Sometimes that's just on there wrong. Like I say, these capacitors will work no matter which way you put them in the circuit. You just get a small benefit by orienting the foil toward ground. And some people say it doesn't even matter. So if you put them in whatever way you put them in, your amp's going to work just fine. So how do we identify the outer foil. One easy way to do it is using your oscilloscope if you have one. My good oscilloscope died quite a long time ago, about a year ago, and it was just too problematic. There were too many things wrong with it to make it work again. It was just too old. So I just got a cheap USB oscilloscope, I think $150 or something, and it works well enough for what I use an oscilloscope for. So how you check this is you take your oscilloscope probe, you put the hot side to one lead and the ground to another lead, and then pinch the capacitor between your fingers and look at the peak-to-peak voltage that you are getting on your oscilloscope. So right now, I'm getting 0.023 volts peak-to-peak. So I will swap the leads. So ground is now on the other lead, and now I'm pinching it between my fingers. And I'm getting about 0.5, 0.52 volts peak-to-peak. So that is noisier. I'm getting a higher induced voltage here. That means that the hot lead is on the outer foil. Conversely, when you do this, the side that induces the least voltage then would indicate that the foil is on the ground. So once you have found that outer foil, take a Sharpie and just put mark a line on the side that indicates the foil. And then you know when you go to install that, you put that side to the most grounded part of the circuit. And as I say, this is something you should check even if they are marked, because they're not always marked right. This is just a jacket covering the internal workings of the capacitor, and that can be on wrong. Again, it doesn't affect the performance of the capacitor. The other way to do that is with something we all have, being guitar players, with an amplifier. You can make a little test lead with I've used an old patch cable here, and at one end it's still the 1/4-inch jack, so I can plug it into an amp, and the other side I have wired alligator clips. In this case, I've got the green one on the ground and the yellow one on the hot. Normally you'd use a green and a red, or a white and a red. These were just the jacks I had. What you can do is very similar to using the oscilloscope probe. You clip this in to your alligator leads. One thing you want to be careful about when you're doing this is we're going to be listening for the noise that's induced into the amp. And you don't want to hold this by the hot lead, because that in itself will induce some more noise into the signal chain. So if you are going to hold this by the alligator clips, hold it on the ground side. Usually when I do it, I just pinch and hold just the capacitor only. We're going to plug this in, and then we listen to the level of noise. Then we will swap that capacitor and see if the noise is louder or quieter. Whichever way is quietest, that means that the ground, again, is on the outer foil. Whichever way is loudest, that means the hot's on the outer foil. So right now I've got the hot on what we marked as outer foil. I plug this in. And then we're going to switch these. So now we're putting what we marked as the outer foil to ground, and the hot lead is on the other lead. We're still pinching in our fingers. We'll plug it in. And we do have a lower level of noise. The larger the capacitor, the smaller that difference between the induced noise or voltage is. So as the capacitors get bigger, it gets harder and harder to tell which way is the noisiest. So that's two ways to test that. So you'll also note that the turret board is here. That's what we're working on today. If you look in the top-down camera, you'll see that I have colored some of these turrets with a red Sharpie. What that means is there's going to be, in addition to turret board mounted components, there will be wires going to off-board components there. So when I'm installing components on here, I will not solder those terminals, because there's going to be another wire or component going in there when we install it, when we start installing the off-board components. On the bottom, I also have marked 4 of these in red. And that is for what we're going to do first, or right now, which is the underboard jumpers. There is a jumper that needs to go from here to here, and a jumper that needs to go from here to here. I have marked those just to make it easy to identify them for soldering. The kit comes with all the wire you should need to put this together, and one of the things you want to be sure about is knowing which wires or which colors of wires you're going to need the most of. So looking at the layout, we have color coding going on here. We have red wires that will be coming off the board, green wires. These ones that are marked gray here will actually be using white wire. We have blue, we have orange, and we have yellow. You want to make sure that you have enough wire for everything you're going to be wiring in here. So we also need 2 pieces of wire for these jumpers that are going to go on the bottom. So I want to use the colors of wire that I won't need so much of. In other words, if you look at this, there's going to be a lot of white wire used. There will be a lot of green wire used. The red wire is actually reused offcuts. And the blue wire we will use a fair amount of, and the yellow we will use a fair amount of. It looks like the least that we are going to use is going to be the orange wire. We'll have a short piece here, a short piece here, and then we will have several short pieces coming off of the turret board itself. So it looks to me like the blue and the orange are used the least. So I'm going to use some orange for this longer jumper and blue for this shorter one. So that's the jumpers installed. So we have the jumper going across here, and this jumper going from this turret to this turret. And one thing I always make sure to do is with these long jumpers that go across other potential connections is I make sure I run that wire so it doesn't go near any other turrets. So when I'm soldering on the other side, I can't inadvertently overheat that turret and melt through the jacket insulation and cause a short. You shouldn't really be heating your turrets to that point anyway. If it's taking you that long to solder something on, you either need to turn up the heat on your solder a little bit, or just make sure you're getting on and off the turrets as quickly as you can. The next thing I'm going to do, and I will do this off camera, is I'm going to place all of the components on the turret board and get them ready to solder. I said I was going to show this off camera, but one thing that I will do, and I covered this as well in a previous video, putting your components on the board and making it look neat. So we have a 50 microfarad capacitor that's going to go at this end of the board across these 2 terminals. So I'll just show you this with that. So here's that 50 microfarad electrolytic. The first thing you want to make sure about is that you do have to pay attention to the orientation of electrolytics. They have a negative side, which is indicated usually by an arrow with a minus sign. That negative lead needs to go in the orientation that the layout or schematic shows. So in this case, the negative lead is going to go to this turret here, which you will see I have marked as a red turret. So that won't be soldered. We'll only be soldering on this end today. You can just take these leads and just, bend them curved and put them in, and as long as things aren't shorting or touching each other, causing potential problems, that's fine, but it looks messy. So it's nice to make your amp look good inside. As I said before, most people won't see the inside of the amp, but techs will, and doing a neat job is just a sign of quality. So start with your leads straight. A little trick that I learned is if your leads are really bent or not, as straight as you would like, you can put them on the end of a table and then take a piece of wood and just roll those leads. And that flattens them almost perfectly straight and flat. So that's just a little trick. So what we want to do is we want to set it so that it's roughly in the middle between the turrets, and then we're going to bend those leads at a 90-degree angle to go right into the turrets. That looks like about here will work. And the other thing you want to do when you're doing this is put it in so that you can read the value on the capacitor. Nothing will drive you crazier than having to troubleshoot or repair an amp and looking at a component and it's upside down, so you can't see the value of it. So put it like that. Same thing with your resistors. Put them on so the bands orient the same way, so that it's really easy to read your components. Like I said, we bend these leads at a 90-degree angle, and they're going to go into the turret, obviously. Once I have the first lead bent, I'm going to trim that lead. Save your offcuts. You can use them as jumpers and things, and we'll be covering that in a minute here very quickly. So now I can put that in, and what I do is I like to bend these so that the lead goes in as tight to the edge of the turret as you can get it, because then that leaves more room for other components to go in that turret. I'm just going to take my needle nose pliers and mark roughly where this one should bend at a 90 degree. Cut that again, place it in, and that's a good one. It's in there. It's nice and tight to the edge of the turret. The writing is visible. We have our negative lead to the end of the circuit that it needs to be going to. There's also a jumper that's going to go between this turret, this one right here, and the one next to it. There is a line here going to a little circled 25.4. This is not a wire or a component that you're putting in. That is a measurement point. It's telling you that you should have about 25.4 volts there when you're doing your voltage testing. So these ones here, this one here going to a circled 280, here off pins, those are not wires going to something. These are test points that you will use to check your voltages. So I'm going to put that jumper in, and we do the same thing. We just bend it at a 90-degree angle. Then we take a look at where we most likely need to bend that. Like I said, you want to try and get these as tight to the edges as you can so you have as much extra room for other components when you're putting them in. If you have a component where, for example, this turret is only going to have these two wires, we don't need to worry about that so much. That would not cause us too many problems. And I will just solder that one turret. You don't want to goop a lot of solder into those holes. You want to make sure that your components are soldered in solidly, but you don't want to put so much in that the solder drips out the bottom. Again, you're probably putting too much heat on that turret if that's happening. And also, if you have other components on the bottom, you could actually desolder those and push those out. Once you have those components soldered in, you just want to give a gentle tug on each component and even jumpers, and just make sure that they're held in there solidly and they're not going to fall out. So all that said, I'm going to go off camera now. I'm going to put all the components in here, and then I'll come back and we'll go through and solder all those points. Well, I got going mounting the components on the turret board, and it was easier and made more sense to solder them as I put them in. I had put 4 or 5, maybe 6 components in, and realized that after I had knocked several of them out several times, I just need to solder these. So the turret board is populated, soldered, except those connections I said I was going to leave dry because they have wires going off board. So here's what we did. All of the components are in. One thing I forgot to talk about was these two long wires going along here and the other one going along here. These are called bus bars. These are the grounding bus for the preamp section. That's this one over here on my right. And for the power section, this one over here on my left. We want to keep the preamp ground and the power ground separate from each other because they can you can get some noise from their interaction if they're connected together. Also, we had a number of jumpers to install between components. Here's one here, here, etc. So I've installed all of the components, all of the jumpers, the bus bars. Everything is soldered except for those points where there are going to be wires going to off-board components. there's a little capacitor here that there will be a wire going off board on both turrets that's connected in. So that is this one here, and then these two capacitors also are not soldered on either side because they'll have wires going out off the board from each side. So I'm going to use a little bit of masking tape just to tape those in so I don't lose them. I'm going to install the turret board into the chassis. Since all of the rest of the work that we are doing will be connecting to off-board components, it makes sense for the turret board to be in the chassis now. When I built the Triwatt, I put all the off-board wires in the turrets from the bottom of the board and coming out. It does look neater, it has a neater look, but it can be really problematic if you have to work on the amp after the fact and you need to change one of those wires for whatever reason that's going to those turrets. Unscrewing the whole board and turning it over. This is solid core wire. You end up often breaking even more wires than the one you're working on, whereas if you solder them into the turrets on the top, you don't have to disassemble anything. It's really easy to take those wires out and replace them if you need to. If you get into a situation where there are just so many wires into the top of the turret that you can't fit another one in to go off board, you can always just strip that wire and crimp it around the outside of the turret and solder it. So it really does make a lot more sense in terms of maintenance and working on the amp to have those wires to the off-board components coming off the top of the turret board as opposed to the bottom. It doesn't look quite as neat, but if you dress your wires properly, it will still look good. So the turret board is secured into the chassis with 4 number 6 machine screws and a lock washer. Those go through from the top of the turret board in the 4 pre-drilled holes, then through some little plastic standoffs to keep the board off of the chassis, and then through these tap screws, screw holes in the chassis. So on the other side, it kind of goes against my whole clean look, having all the machine screw heads being on the outside of the chassis, but that will just be 4 sticking up, and I don't think they'll look too out of place. Again, one of those things that it won't bug me if I don't let it. Okay, so the turret board's installed in the chassis. Now is a good time to just double check that you've got everything installed there properly. So a layout is basically like a tab is to sheet music, a layout is to a schematic. It's basically a map of where all the components and connections go. It's not a schematic, and sometimes it can be a little bit difficult when you're looking at a layout to know exactly if something is just a line or a wire connecting something. So it's good when you're referring to the layout to also have the schematic so that you can refer to that and you can look at the schematic and go, okay, yeah, these 3 components connect together. That's not anything connecting to it. It's just a line. The layout is really handy, though, for people who don't know a lot about electronics or even to know how to read a schematic. It makes it really easy to lay out all your components, connect them, and end up with a project that works. Because it's really easy to work with a layout, there can be a tendency not to read the instructions that come with your kit. And you really should do that. I do it, and I could probably do a lot of this stuff in my sleep. But you never know what little bits you're going to miss, what little instructions that are not clear on the layout. And that can be clarified in the instructions. I spoke with somebody recently who had built an amp very similar to this one. Once they got it all built, they were quite excited to fire it up and play it. Well, they turned it on and no smoke or anything, but no sound either. And they went back and looked over everything very closely and realized that building from the layout, they had not noticed a few things. One thing, for example, is the jumper wires that go on the bottom. They are drawn in dotted lines. That indicates that they're on the bottom. Some people I have seen actually omit those jumpers altogether because they didn't know what that dotted line meant. It means that's a jumper on the bottom of the board. So if you miss that, your amp isn't going to work. Other things that people don't really notice so directly on the layout is the heater connections, for example, to the 12AX7s. Your heater supply goes to pin 9 of the 12AX7 and to pin 4 and 5. So those two connect together. Because of the way it's drawn in here, it just looks like that wire comes in, hops over 5, and connects only to 4. When you read the instructions, it tells you explicitly pins 4 and 5 need to be connected together. There are a number of things you can miss on a layout. Being able to read a schematic can help you sort some of that stuff out. The other thing, as I said earlier, all of these lines going off to these little bubbles with the numbers in, those aren't wires going anywhere. Those are test points and telling you what voltages you should find at those points when you're doing testing. It's not important if you can't read a schematic. It's not a do or die thing. You'll still be able to build your kit. Just be really careful paying attention to what you're doing, working from the layout, and read the instructions. If you can read a schematic, great. If you got any questions on what the layout's telling you, you can refer to the schematic and sort it out for sure. The schematic will always tell you exactly how that should be connected. Basically, the only things left to do for this amp are to connect all the outboard components, the front panel controls, the back panel connectors. We have some components to mount on some of the front panel controls and jacks. We also have some resistors and things to mount on these terminal strips. We have to finish wiring up the tubes. You can do it in an afternoon pretty easily. So hopefully next video we'll get all of that connected and have the amp ready for testing. So until the next video, please like and subscribe, share my video. I do answer comments. Any things like that you can do help get my video seen by a wider audience, and I would really like to reach more people with this. So if you find this entertaining and informative, please spread the word. Like always, the links to my band One Soul Thrust are in the description below. Please check us out, and if you like what you hear, consider supporting us on Patreon. Until the next video, have a great week, and we'll see you.